Nuttall of Tyne Marine Services. Jonathan is a master mariner with 27 years offshore experience, of which 14 years offshore construction management, with experience in wind, wave and tidal renewable projects. He has worked on a majority of UK offshore wind farm construction projects for developers such as E.ON, RWE, SSE, EDP, and as an offshore installation manager, and also an offshore construction manager. And he also does client representatives. So he's a well-experienced individual, and I hope and I know you will find this an interesting evening tonight. So back to you, Paul.
Thanks, Sean. Thanks for the introduction. That's brilliant, fantastic. And obviously, John, we ran through the presentation earlier, didn't we? So hopefully it's going to all be that. So if you just want to unmute yourself and get underway and share your screen, that would be fantastic.
Okay, let me know if you can see it.
Yep, all there, all up and running. Brilliant, John. Thank you.
That's great. Okay, well, thanks very much. So, yeah, offshore wind farm construction. Obviously, it's a huge topic which I could drone on about for hours. So this is just a brief overview of all of the main, or at least the majority of the main elements of an offshore wind farm and how it's constructed. And I'm lucky enough that I've worked in pretty much all the different scopes in an offshore wind farm. But so please feel free to ask any questions and that, and hopefully I'll be able to answer them for you. And if I can't, I'll be able to find out and get back to you. So I thought I'd break it down a bit. So these are the topics I was going to cover. I'll run through some of the regulations and the health and safety side. And then the different parts of the wind farm, which are basically broken down into foundations, turbines, the substations, and then I've got a bit at the end about the new sort of foundation designs that are coming through. There isn't a section on cabling because that's not my sort of main area. I've done a few cable jobs, but I'm not going to go into any detail on that. So. Okay, so regulations wise, wind farms are pretty interesting actually from a HC point of view, because basically they come under the same rules and regulations like any other UK power station construction project. So you've got all your Health and Safety at Work Act and your Management of Health and Safety, your PUE, your LOLA, and then your CDM regs because it's a construction. But then in addition to those regulations, all the vessels are bound by IMO conventions like SOLAS and MARPOL, STCW 95, MLC, that's the Maritime Labour Convention. So these conventions are worldwide for all shipping, and then they're ratified into UK law and come out as merchant shipping regulations. Or port state and flag state regulations. So as you can imagine, trying to sort of fit in with the CDM regulations is pretty challenging because it's a construction site that's offshore. So you can't just build a Harris fence around it, for example. It's that you have to apply for a safety zone, and then you have to monitor it using guard vessels and a marine coordination center, and monitor the shipping using AIS and radar. So that's all ships give a signal telling everybody in the area who they are and where they are, and we can monitor it like that. So it's not as simple as just putting up a fence and having some security guards on. Sadly, we can't make exclusion zones for an offshore wind farm like you would around an oil and gas project. We're only allowed what's called a safety zone, and that enables fishermen and people like that to be able to transit through the construction site during construction operations. And that's kind of to keep all parties happy. So the seabed belongs to the Crown, and then the wind farm, the energy companies apply to build on a section of seabed that's been sort of allowed to have a wind farm built on it. But the fishermen and other traffic still have rights to be able to go in there. So, yeah, so, but in a lot of ways, it's still done the same as any other construction site onshore. So, for example, you know, we still all have inductions, everybody is recorded, all their qualifications are recorded, you know, and then personnel are still tracked around the site. It's not as easy as it is on a normal construction site, but it is done. So we have a system, normally a computer-based system, and we can click on any asset. So on any turbine or vessel, we can click on that and see exactly who is on that asset or vessel. And then you can click on the person and then check all their documents, check that all their medicals are in date and all their courses are in date and stuff like that. And when people transfer from one vessel to an asset or from another vessel to another vessel, we actually transfer them on the computer system as well, either manually, or some wind farms now have a system where everybody has a card, a swipe card, and you swipe on and off the vessel and onto the turbine, so that, you know, it's really easy to track people in the event of an emergency, which is really good. Probably the most important, for me anyway, the most important sort of document that we use because of all this is a bridging document. So that binds together all the legislative requirements and the different HSE policies and procedures. From, you can imagine, we've got loads of different contractors, they're all from different countries, loads of different vessels, all from different countries, different flags, and then you've got all of the UK legislation as well. So to make sure that we're ticking all the boxes and everyone's pulling in the same direction, we have a really detailed bridging document, which brings it all together. And I'll leave the details of that on the document, which I'll leave for you to refer to later. But yeah, so the sections, we'll talk about foundations. So I've put there MP and TPs, that's monopiles and transition pieces, which is your standard foundation. And then we've got jackets, gravity foundations, and floating foundations as well, which are what they say they are really. The jackets are like a lattice structure, which you can actually see there in that photograph. You can see it's like a lattice structure, and then a gravity foundation is normally made of concrete and just sits on the seabed rather than penetrating into the seabed. Substations, they're required onshore and offshore. So generally you'll have the cabling coming from each of the turbines will go into an offshore substation, normally at 33 or 66 kVA. And then it's kicked up with a transformer up to 150 or 220 generally. And then it gets sent ashore on the export cable to an onshore substation where it's kicked up again then to 440 for the grid. There's cable installation as well. So we have two different types of cables on a wind farm. There's the export cable, which runs all the power from the substation ashore. And then you have the array cables, which go from turbine to turbine and then into the substation. And the cables aren't just power cables. They've also got a fiber optic line in them as well. So that's how we communicate to the turbines and tell them what we need to do and get all the information from them. Then obviously the turbines go on. So you'll see those referred to as WTGs, that's wind turbine generators. We don't call them windmills, they don't mill anything anymore. And then you've got the completion works at the end. So we make sure that there's no scour going to happen. That's probably one of the biggest problems that we get after construction. That's where the tide runs, when the tide runs past an object which has been put on the seabed or driven into the seabed, it creates a hole around it, which can just get bigger and bigger until eventually the turbine will fall down. So we put rocks and stones normally around the bottom of the turbines if it's in an area which is prone to scour, which in the UK it normally is because of the sort of tidal flows that we get. Okay, so foundation installation first. So this here is this is a typical foundation installation vessel, the Pacific Orca. It's a 6-legged jack-up vessel. It's actually, the hull is actually in the water in this photograph, and that's because I took the photo when I just got off. So that we jacked the ship down so that the hull is just touching the water line, and then you can see the white ladder there on the ship's side. That's so that we can climb down that and onto the CTV, which is taking us ashore. So just after this photo was taken, then they would have jacked back up, clear of the water, and carried on with the installation. So what you can see there, the yellow tube, the vertical tube, that's a TP, a transition piece. And then poking out of the side there to the right, you can see monopiles. So the monopiles are what is driven into the seabed. And then the yellow transition piece is then lowered down on top of the monopile, and that creates a transition for the, a platform, for a flange for the turbine to get installed onto. So here's a monopile just before being loaded out. It's kind of hard to gauge the size of this actually. Sadly, there's no people in it for reference, but this is a 1,000-ton monopile, this one. And the sort of details that you can see. So the grey bit in the middle is the bit that will actually be in the water. That's the bit that will be underwater. So if you look to the right, the rusty part, that's the toe of the pile. So that's the bit that'll be driven into the seabed. And then you've got a red and a blue hull. They're cable hulls. So the seabed will actually, it will get driven until the seabed is just below those two, where the colour goes from a dark grey to a light grey. That's where the seabed would be. The cable hulls, obviously, where the cables will come up through, because then the cables come up in the middle of the monopile. And then it's actually tapered if you look at the top. So to the left, you can see it's slightly tapered. And then the rusty part to the left then will be inside the transition piece. So that's why that's not coated either, because that will actually have grout or cement around it. You can see to the left there, there's an N, a north mark. So the orientation on this has to be correct. And that's because the wind farm is designed for the cables to come in, from the direction of the previous turbine location. So it all has to be done correctly. And then we've got the yellow and black mark by the cable holes. That's the center of gravity mark for us as we're about to lift it. And then you've got a clear yellow line painted on either side of that, and that's our location for the slings just before the lift. So here we can see the monopile being lifted. Yeah, so it's quite a big lift. We use a spreader beam for that one, and I think that was in Vlissingen from memory. Yeah. So we then, once we've loaded out the components, we'll jack down and steam out to site. So that was loaded in Vlissingen. I think this was actually on Rampion wind farm, this photograph. So we then jack out to site and we position the vessel very accurately using a computer system called dynamic positioning, which I won't go into now, but it's to the sort of plus or minus ½ meter kind of accuracy that we're getting on that. And once we're jacked up, then the first job is to upend the monopile. So if you have a look on that photograph at the top there, you can see there's actually a tool. You can see 2 slings going into some eyes. Well, that's actually a lifting tool, which is internal, and it's activated hydraulically to grip onto the top of the pile. And then it's lifted up, and it's lifted up in a pivot, what we call an upending bucket. It's basically a pivot system at the toe of the pile there. The crane then lifts up and slews and gets the pile vertical. And in that photograph, it's gone vertical and the pile's being lifted out now, out of the pivoting system you can see there. We then slew it round, and on the stern of the vessel, we've got what's called a gripper. This is a pretty interesting piece of engineering, actually. There's quite a lot to it. You can see a hydraulic arm there. So it's designed to be able to move. It's got about plus or minus a meter in every direction. So that allows for any minor inaccuracies in the vessel's positioning. We put the pile into the gripper and close the gripper arms around it, and then we slowly lower it down. And the surveyors will then measure it and make sure that the pile is as accurate as possible. So at each location of each turbine is already defined and it's already planned. So we try and get it as accurate as we can. You can see at the top of the photograph there the cable holes. So again, we'd maybe have to reorientate the pile to get it absolutely spot on. And we lower the pile down to the seabed and let it penetrate under its own weight into the seabed. And this is a one-way road, because once the pile goes into the seabed, to lift it back out again, the pile would be heavier than it is just to lift it in air, because you'd now have added skin friction with the soil onto the pile. And that means that all the lifting gear and the crane itself are not rated for that sort of weight. So once you've touched it down and you've let it self-penetrate in, and it normally will penetrate a couple of meters, that's it. There's no going back at that stage. So you allow the pile to gently self-penetrate, and when the slings at the top are slack, you leave it for a little while just to make sure there's no movement, and then we release the tool automatically with a remote control. And the pile's now kept in the pile gripper. We then measure the verticality of the pile and adjust that so it's absolutely spot on. And the next step is to put the hammer on the top. So here's the hammer going on. This is actually the biggest hammer in the world. This is a 3,500 kilojoule hammer. So it's a bit of a beast. And obviously once that goes on, that weighs about 600 tons. So once that's on, again, there's more self-penetration with the hammer on the top. So that will sink down probably another couple of meters at that stage. Once it's all down, then we can't start hammering. And the reason for that is I've put there MMO requirements. That's the Marine Mammal Organization requirements. So in order to get a license to build a wind farm, the developer has to satisfy all the requirements, and one of those, or some of those requirements, are looking after our marine mammals as well as birds and other life and fishermen as well. So what we do is we take observations. We'll have a separate vessel normally going round and round, taking observations visually, and then they will put what's called a seal scarer, which is basically an acoustic device which goes in the sea and delivers like clicking noises, which marine mammals don't like, and they disperse from the area. And once they've been doing that for a set period of time and they haven't had any sightings of any mammals, then we're allowed to start piling, but we can only do it very, very gently. So we have to just tap it on minimum energy a few times to kind of scare away any mammals that might be in the area. And then we very gradually start to ramp up the power. But I mean, this fits with how we do it anyway, because just one tap and the pile will sink, and then we tap it again and it will sink again. And each meter that it drops down, we stop piling. I'd get the surveyor then to do another measurement and just adjust the verticality to make sure that it's absolutely spot on plumb. And then we go down and we do it a meter at a time. And then once you've got a few meters penetration and the pile's looking pretty stable, then you'd start going into what's called sequence. So the hammer is then just delivering a blow about once a second, and it just carries on going then. And then eventually the hammer and the pile will reach the gripper. And then we'd release the gripper, then the pile would then be penetrated deep enough to be able to support its own weight plus the weight of the hammer on top. We carry on driving that down into the seabed until we've reached the required penetration. I put there pile limits and refusals. So sometimes if we're in some really heavy ground, we can run into problems. There's two problems really. One is that the hammer actually can damage itself. If the pile's not moving, you're driving it, or you're trying to drive it into rock and there's no movement. What happens is that all the energy that is coming out of the hammer just rebounds back up the pile and back into the hammer, and it'll actually damage itself and break itself. I mean, these are pretty temperamental bits of kit. They're right on the sort of edge of what we can do. So we have to monitor it very closely, and there's set limits to what the hammer, where we have to call a refusal. And the other reason why we could refuse is because of the pile itself will fatigue. So we monitor very accurately how much energy has gone through that pile. And if it looks like we're not going to be able to get it to the required depth without reaching the limit for pile fatigue, then we'd have to stop piling and come up with another plan. We may have to drill it. So that's quite an art in itself. Yeah. Okay, so once that's at required depth, we then put on the transition piece. So here's a transition piece in midair. You can see, so what you can't see, if you look around the bottom of the tube, if you like, there's actually a rubber grout seal in there, but it's not a very good photo, I'm afraid. And that slides over the top of the pile, and then when you pump the grout into the annulus, that's the gap between the inside of this TP and the outside of the pile, it stops the grout all falling out the bottom. So it's just like a rubber wiper, really. Around the bottom of the transition piece there, you can see anodes. There's a lot of them because they won't be changed. It's not like a ship where you can change them every few years. You know, those anodes are there for the life of the foundation. And then you can see the ladder going up. So that's the boat landing. That's how the technicians will get onto the turbine in the future. And there's bars either side of the ladder there, which the crew boat will push onto. And the guys go over the bow then to transfer onto the foundation. There's the foundation installed then. You can see we just finished just lifting the gangway off. So you can see the platform. That's the access platform. You can see the ladder on the other side there. So that's why the guys would come up. Each foundation has on it a little davit there, which is for lifting up the guys' lunches, basically, and a few light tools. Nothing much, but you know, it means that the guys can climb safely without having to have rucksacks on their backs and stuff like that. Each location is numbered. And then on the top there is a little tent. So that's just to protect the flange until the time that the turbine installation vessel comes along. That's all, keeps it all dry and nice, ready for the turbine guys. Okay, so here's the next step then, the turbine installation. So here's a turbine installation vessel. These are Vestas V12s from memory. So these are actually fairly small turbines now by today's standards, believe it or not. Yeah, I mean, that ship there's carrying 8 turbines. That ship now is outclassed. It's only got a 1,000-ton crane on it, and it wouldn't be able to have the reach or the capacity for some of the bigger turbines that are coming in now. But anyway, you can see there's 8 tower sections. These tower sections are fully constructed in the loadout port. They've even got a lift in them, and it's wired up and working. So that means the riggers, when they go in, they don't have to climb ladders anymore. They just go in up the lift to connect the lifting tool. You've then got the blades there, which are overhanging over the starboard side of the vessel. And you can't really see, but down the middle of the vessel in the main deck then is all the nacelles. So that's the actual generator section that goes on the top of the tower. So when we load out in the loadout port, that's quite a big job in itself. You can see there we're loading 3 blades at a time in a stack, which is quite hard to control in the wind. So wind limits for these lifts are pretty sensitive. We've got a traverse system, like a tugger system, which controls the orientation of these lifts, but even so, we're normally limited to around 12 meters per second for these sort of lifts. So once we've jacked up, positioning on these is still very important because we don't want to back into the foundation that we've just spent millions installing, but it's not as necessary to be quite as accurate because, you know, we can only put the tower on the foundation. So you can actually see there the propellers and the quart nozzles there on the ship, which is interesting. And you can see on the starboard side there all the blades overhanging. And this was, again, this is Rampion. And you can see the vessel's nearly at the top of its legs already. And that's a relatively shallow wind farm by today's standards. It's just, it's getting deeper and deeper now. So there we've just installed the tower. And if you look at the crane hook, it's just landing the lifting tool. So that tool just clamps onto the top of the tower flange and it lifts the tower in one piece. That tool actually can orientate the tower remotely so that there's no sort of hands-on with the tower at all. It's all done on the crane with tugger winches. So nobody needs to get anywhere near the tower. A few years ago, we used to land the tower with guys actually stood inside the flange on the TP. But with liaison with the health and safety executive, we've actually come up with systems now where we can land the tower without anybody having to be on the transition piece. It's all done with cameras and, as I say, remote orientation devices on the lifting tool. So things are getting better and better all the time. Just as a side note, these towers, they can't just be left. They can't actually be left on their own without a nacelle on, because if it gets windy, they actually start to oscillate, and they're designed to cope with wind speeds with the weight of a nacelle on the top. So when it hasn't got the nacelle on the top, and a nacelle typically weighs about 400 tons, the tower will oscillate and it could destroy itself. So we actually have a damping system inside the tower, which creates like a free surface effect at the top of the tower and sort of mimics having a 400-ton nacelle sat on the top of it. You can't see it there because it's internal, but just thought I'd mention it because it's quite an interesting bit of engineering. So next lift then is the nacelle. This is 2 different types of nacelles. The one on the right there is a Vestas unit, and the one on the left is actually a Siemens unit. They're the 2 sort of main players in the turbine game, but they're reasonably similar. So yeah, you can see the yaw section at the bottom of the nacelle there, which will bolt onto the top of the tower. And once it's bolted on, they also have to wire it in and get power to it so that they can yaw the thing around, so rotate the thing around so that the hub is in the right place for lifting on the blades. So it's not just as simple as screwing it all together. They have to actually, you know, get the thing working. And then last, obviously, is the blade installation. So the picture on the left there, you can see that's actually the last blade on deck. That's the tool that we lift it up with, the blade gripper, and that's a pretty good bit of lifting kit in itself. I don't know if you can see there, but there's actually rollers at the top. So where the little slings come down from the crane hook, that the center of gravity can actually be adjusted. They can roll right and left to get the thing absolutely horizontal as they're lifting it. It's then lifted up, slewed around, and you can see in the photograph on the right there, that's the blade coming into the hub section, and then there'll be guys actually in the hub, and they are directing the crane operator from up there. and it's quite tricky trying to get the bolts into the holes in the blade bearing. That picture on the right there is the end of Moray East offshore wind farm. So that was the penultimate turbine being put on there. And if we going back to foundation design, so that's, you can see there the difference. These are actually jacket foundations as opposed to monopile. So we'll go on to that later, but you can see it's like a lattice structure. Yeah, so once the turbine's on, obviously the wind turbine installation vessel is really, really expensive. So the idea with that is that we will use the minimum amount of time possible to put the turbine up. We'll do absolutely bare minimum. We will bolt it together and we'll connect up the electrics so that we can yaw it round and make it safe. But that's it. And then we disappear and do the next turbine and the next turbine and the next turbine. So what then happens is a commissioning team or several commissioning teams then go around the wind farm and they get the turbine actually up and running. So they do this in a number of different ways. The vessel in the middle there, the Acta Centuris, so that would be the commissioning vessel. So guys will be living on there. And they will either go to, if the weather's like it is in that photograph, they'll generally drop down onto a crew boat or a CTV, which is the one on the right there, which will ferry them around to the different locations and they'll climb up ladders. But the weather limits, the wave limits on those are actually pretty tender. So what they've done to reduce downtime, if it's too rough for these boats to work, they've come up with a gyro stabilized gangway for the commissioning vessels now. And we call it a walk to work vessel. So they actually don't have to go onto these crew boats anymore. The commissioning vessel will come alongside the turbine, and the gangway, which you can see on the left there, actually comes out and meets the turbine. And even when the ship is rolling and pitching and moving, the end of the gangway stays perfectly still and pushed up against the turbine, so the guys can safely move across. Now, I took this little video on the one on the left. Sadly, I didn't see it coming in, didn't catch it, but I caught them retrieving the gangway, so you can get a bit of an idea of how it moves. So I'll just play that for you. Yeah, so that's them withdrawing the gangway and then moving away. But you can see it's mounted on that mast there, so they can access really high foundations if it's low tide, and there's quite a lot of movement, and it moves surprisingly fast, but it has to account for the vessel rolling when she's moving in a seaway. So yeah, they'll get the turbine up and running, and once it's turning and burning and producing electricity, it will then get handed over to the client, and they can start making money. Oop. Okay, and then this is a typical offshore substation. Again, it's Rampion. It's another one. I was site manager for this one. So you can see this is on a jacket foundation again, but it's a much bigger jacket foundation than you'd have for a turbine. This one was drilled and piled. And then what we'll do is once it's installed and lifted on, we generally have a jack up ship come alongside, and that's used then as just like a hotel really, so that the commissioning guys can walk back and forth. There's quite a lot of commissioning to happen on a substation before it can work. And then you can see all these tubes coming down, and this is all the different cables. These are all the different array cables coming in from all the different strings. And then I don't know if you can see these two here are a bit thicker than the others. So they're the two export cables. So they're the ones that will take the energy ashore. This was a jacket that I installed last month up on Beatrice wind farm, and this was a monster. This was a 5,500 ton jacket, this one. which has 6 legs and 2 piles on each leg. So it's 12 piles driven in, and then it'll be a pretty substantial substation that goes on there. That's not here yet. So this vessel actually bought it round from Dubai, this jacket, and then we lifted the jacket off on a vessel called the Saipem 7000. So this is a picture of us on the Saipem 7000 taken from a crew boat. This is a beast of a vessel. It's got the two cranes there, 2 7,000-ton cranes. So we lifted the jacket off and then down-ended it. You can see it there halfway through the down-ending process. It's down-ended and then landed on the seabed. All the rigging's taken off, and then we install the piles and drive the piles. Yeah, that's it when it's finished. So the piles are driven subsea, so we use ROVs to see where we're going with that, and the piles get put into the pile sleeves, and then hammers stuck on the pile and driven into the seabed. And then the connection between the pile sleeve and the pile again is grout, just like it was with the TP. So it's a sort of high performance polymer grout that's injected down into the annulus, and then it sets, and then that's your jacket installed. Yeah. This is a substation topside lift. So this is the actual substation going on. This is on a different project now. This one more east, I think. So you can see there, if you look on the photograph on the left, you've got the stabbing cones there, which so going into the female guides there, which are actually on the jacket itself. And then if you look closely, you can see the orange hydraulic jacks, which were used for the leveling process on this one. This is actually a really small substation, but meant it was nice and easy to install. Yeah. So, yeah. So again, this is just another photograph I had of the ship that I was working on, jacked up on the substation whilst we did the commissioning works. This is a typical wind farm installation vessel. This one's good for turbines or for foundations. This has got a 1,400-ton crane on it, so it's quite a good one. 6 legs, nice and stable, and a really good DP system as well, so really good for positioning. Yeah, so I thought I'd include this. So this is the yard at Nig, where we've been loading out the jacket foundations. This was just to give you a bit of an idea of the size of them. If you look at the jacket on the right, and if you look closely, you can actually see those little black dots of people. They're painters on ropes, just doing a few finishing touches to the jacket. So then that gives you a bit of a sort of scale, really. These jackets, so these are the turbine jackets, and these ones are pre-piled. So when you're going to do a lot of them, in this case, there was 100 jackets, 100 turbines, you go around the field with a slightly smaller vessel, and you have a template to pile through. So we put a template on the seabed and then drive the piles. These are tripod jackets. So you drive the 3 piles through the template, then you move on to the next location and repeat, and just keep going. And that way you can do that. That's time consuming with a much cheaper, smaller vessel, because the piles are only about sort of 200 or 300 ton. So you can get away with I think we did it with a ship with an 800-ton crane on it, which is, I know it seems quite big, but it's actually a lot smaller than the installation vessel that's required to lift these jackets, because these jackets are 1,300 or 1,400 ton each. So that's obviously a much more expensive vessel, and that means that we could come in, pick up these jackets, go out and just install them, bang, bang, bang. It was a much quicker, a much more efficient way to do it. But yeah, these jackets have got all the same features as the monopiles, really. You know, you can see the J tubes that the cables will go up through. The legs at the end, obviously the legs are canted, and then at the bottom they're vertical, and that's because that's the section that will go into the piles that are already pre-installed, that we've done through the template. And then the last type of jacket, which is the ones I'm actually doing at the moment, these are suction caisson jackets. So these ones don't involve any piling at all, and that is really beneficial because it means that we don't have any issues with the MMO guys. So the marine mammals are happy. There's no loud bangs. But most importantly for this project was that there was very, very hard ground after about 15 meters into the seabed. It went very, very hard. And that would have meant that if we'd have done normal jackets, they'd have had to have been drilled, and drilling is very, very expensive and hugely time consuming, and it's pretty high risk too. Well, with this, the top 15 meters of seabed strata is sand mostly, and that meant that we could use this type of design. So what we did here was we put the jacket onto the seabed, and we actually sucked the caissons down into the sand. And once it's they generally were going in about 12 meters, were designed for. You can see the red line on the caissons. That's where the seabed is meant to be, and that's it, done. So installation was pretty quick. No pre-piling, no templates, no expensive hammers to hire. It was actually really good. The downside is that they're very heavy because you've got the weight of the jacket plus the weight of the caisson. So effectively you're lifting a jacket with 3 piles hanging off the bottom of it. So you have to have quite a big installation vessel, but certainly it's got its advantages. So I don't know if we've got time, but this is a little video of the process, of that process, which I've been doing, which I can talk you through. Video says 1,000 words. So here's the project. We loaded out the jackets at Nig. Again, it's a pretty popular port at the moment for these Scottish wind farms. And then the wind farm was there, just to the east of Dundee. There's the Saipem 7000, so the same ship that we did that substation jacket with. So the jackets were coming in 2 at a time on a barge, coming alongside. The barges actually were slightly under-spec'd, so it was quite tricky. In this Scottish winter, we had quite a few weather days, sadly. But they did the job. So yeah, each the 2 tugs then hold the barge steady whilst the Saipem 7000 comes alongside and then makes it fast. And then people are transferred. Then you can see there's a crawler crane on the deck which does the personnel transfer. Those guys can then get ready. So this is the back loading of the guides. These are the guides at the top of the jacket which just help us to locate the lifting tool, which you'll see later. So here we can see the pumps being put onto the caissons. These are a new pump design from a Norwegian company that we hadn't used before, but they seem to be pretty good actually. And there you can see there's a catcher on the bottom to make it slightly easier for landing. And on it goes. And then you've got the hose then coming from the pump and onto a launch and recovery system. So that's just repeated 3 times. For the 3 different caissons. So here's the lifting tool. So obviously we need to be able to install that onto the top of the jacket remotely, because we're not going to send any people up to the top of the jacket whilst it's on the barge. And there, in this video, it looks absolutely perfect, but in reality, you know, the barge is bobbing up and down, rolling around. The vessel has a little bit of movement in it as well, so it gets pretty boisterous up there. There's a load of cameras on this tool, so we could see what we were doing, but it wasn't quite as neat as this presentation is making out. But you can see there the guides. So that's the guides that we were backloading at the beginning there, because obviously these guides will come off after installation, but you'll see that later. So that just locates it nicely down onto the flange. And then we remotely operate it and clamp it shut. And you can see the way that it's done there, that if any hydraulics fail, it's actually, we wouldn't be able to get it off, but it'll be completely safe because the weight of the jacket is what's holding it in position. So once it's on and everybody's happy, we're all happy that we've got the right weather window and that the conditions are right and all the kit's ready, then the guys on the barge then will cut the sea fastenings. So the jackets are actually welded to the sea fastenings and they have to be gas axed or gouged off. And then once that's done, we recover all the guys off of the barge and all of their cutting equipment, and the jacket can be lifted. Yeah, we then move clear of the barge rather than the other way around, because the Saipem 7000's got a full DP system, so it's a lot easier to move that than it is the barge. That clears off. And then we'll move into the exact installation position and hold there on DP again, on dynamic positioning. And then down it goes. And again, just like I explained with the monopile, you know, once this goes in and it self-penetrates with its own weight, it's a one-way street. There's no coming back out generally. There'll be too much skin friction. To recover it. So then you can see at the bottom there, the ROVs then. They're keeping an eye on everything. There are eyes. Yep, so once we're happy with everything, we start the pumps. And the suction begins. And we can actually adjust the level of the jacket because by just sucking more on one caisson than the other. So we keep it completely level the whole way down. And the deeper it goes, the harder it is to keep it level. So you sort of keep on top of the level from the beginning, just like you do on a monopile. Once it's down, then the tool can be released. And then we recover the pumps then, ready for the next one. And then last but not least, we release the guide. And that will get sent back to NIG then on the barge, ready to be put on the next batch of jackets. And that's the flange that the turbine tower will eventually go on. There we go. So yeah, that's it. So ready for any questions if you've got any.
Okay, great. Thanks, John. Thanks so much. Sean, are you okay to take John through some of the questions that have been raised through the chat? Is that okay?
Give me a second, my signal isn't great.
Yep, no problem. You're a little bit quiet, Sean.
Yeah, sorry.
It's okay.
Okay, here with me, just pulling it up now. So,
Yeah, that's perfect, yeah. Great. So thanks, John. That's brilliant. Thanks so much, and thanks everybody for all the questions. So I've got plenty of things coming through the chat. So, Sean, if you want to just take us through that, that would be most appreciated.
Right. Okay. Bear with me. So, hi there. This is from Galina Hobson. Hi there. A member of East Midlands IOSH committee here. HSE manager for rope access company working in wind industry as well as others. So I can't see the question on that particular there. Right, bear with me, I'm just scrolling down. Have I got the right? I'm in the chat box here.
Yeah, that's correct, Sean. Yeah, I think people have just been sort of introducing themselves as well. There is one from Nick Jones just a little bit further down. Let's come down to that one.
Nick Jones, there we are. Right, okay, sorry about that. So in North Wales branch, we tried to arrange a site visit to an offshore Gwynny Moor, but we're sniped by poor weather conditions on about 3 occasions. How often is bad weather an impact on construction?
Yeah, quite a lot actually. It depends what you're doing. It depends what the task is. So different lifts have different limits. Turbine installation is sort of has the lowest limits, specifically blade lifts. So that tends to be what stops you the most. The limit there is 12 meters per second, normally at 100 meters. So yeah, I mean, but having said that, you know, there's other jobs that you can do where you're not really limited by weather. I was construction manager on Gwynty Moor, and I remember being out there drilling in sort of 60 knots of breeze, and it was absolutely fine because there was no lifts going on. We were on a jack up. The drill rig was, you know, stable. So and we were still working, but obviously anything related to lifting is limited by wind limits, which is set down by the marine warranty surveyor and by the installation contractor. And for a site visit, on Gwynty Moor, you'd be limited to transfer limits off of a crew boat, which are normally around about 1.5 meters HS wave height. But if you're taking visitors out there, you know, they're novices at climbing, you're probably going to drop those limits slightly as well. So it can be pretty tricky. But that's where those commissioning vessels come into their own. You know, they're fantastic. Those things can put people safely onto a turbine in sort of 3 or 4 meter seas, and with that gyro stabilized gangway, it's absolutely, you know, it's a game changer for that. So it depends. Yeah, so a lot of it depends on the kit you've got.
Okay, thank you, John. Another question from Nick Jones. In fact, he's got two. So the first one is, in view of today's oil spill north of Rhyl, what are the risks of maritime pollution from these turbine generators?
I have known some pollution from them, but not very much. So all you've really got in there is hydraulic oils, which are generally contained within the turbine. They can't leak out, and they're all kind of environmentally friendly oils as well. So the only time you've got a real hazard is during the construction phase, before the cables are in and energized. We generally will have a generator, power pack, and a fuel tank sat on the turbine to supply power to the turbine. And that's just to keep the heaters going and the dehumidifiers going. Because you're talking about a £9 million piece of kit in a marine environment. So we have to keep it, you know, warm and dry. We have to be able to move it a little bit. So before those cables are in, you've got a generator on there. You could potentially have a spill from that. But, you know, as you can imagine, all tanks are double bunded, double skinned. All hoses are double skinned. You know, we have a lot of sort of belt and braces on all of that kit. But I have known for there to be small hydraulic spills from the turbines that have come out of the hub, but nothing's ever reached the water that I'm aware of.
Okay, thanks, John. Next, second question is there much of a risk from unexploded underwater ordnance?
Yeah, there is. It's pretty interesting. Yeah, so before we go in onto a site with a jack up, we have a full UXO survey done, as well as other surveys. There's a lot of soil data that comes in. I mean, the foundations themselves are designed based on surveys of the seabed and what it's made up of. And one of those surveys is a UXO survey. So the site's very thoroughly surveyed, and then any UXO is removed or exploded before any jack-up vessels come on site. Because obviously once we come in and put our feet down, we don't want to get a leg blown off. The worst one was Rampion. That was really bad because the British planes used to come back. Any damaged planes coming back from Germany would jettison their UXO over the English Channel before they got over land, and that was right where Rampion was built. So there was quite a few there, and there was a few in Gwynty Moor actually, North Wales. Yeah, because same thing, people miss it. I think there's a few planes that missed Liverpool. Yeah, so yeah, we do. That is a problem, but it's something that there's a lot of money spent on to solve. Yeah.
Okay, thanks again, John. So Galena Hobson has asked, do you often use rope access for construction?
No, we don't use rope access during construction at all. Rope access is used onshore, as you saw in that photograph of the jackets in Nig. That was for paint inspection and repair, but we don't use it generally offshore if we can help it. We wouldn't use it on a construction vessel. We do use it if we absolutely have to from a commissioning vessel to do blade repairs. So sometimes during a lift of a blade, you might get some damage. And if that happens, then we'd send rope access guys out to do blade repairs. Yeah, and blade repairs also get done during the operations and maintenance phase in the event of a lightning strike. When you get a lightning strike, it will take the tip of a blade, it will damage the tip of a blade, and then guys go in on ropes to repair that out of the hub. I wouldn't fancy it, but they do, but generally not during construction, no.
Okay, thanks, John. Back to another question from Nick. So what is the end of life recyclability of these structures if it is not possible to withdraw piles once in place or once put on the seabed?
Pass. Now, I mean, the turbines are generally designed for 25 years, and so the foundations initially are for 25 years. But I would imagine that when 25 years comes, there will be a lot of survey work done to them, and they will probably stamp them for another 5 years, and then another 5 years, and then another 5 years, just like they've done with the North Sea oil rigs. I would imagine they'll get a lot more years out of them than the initial design. I wouldn't be surprised if the turbines are taken down and bigger, more efficient, better technology turbines are put up on the same foundations in their place. But eventually, they'll be shot. And I have actually removed 2 turbines from a Scottish wind farm, Robin Rig, and what we did there was we cut the monopile off or about 1 meter below the seabed using a high pressure water and grit cutting device. So the pile that's below the seabed will be there forever. There's no getting that back. That's gone. But but the top section that comes through the water column, that we would retrieve that, I would imagine. Yeah.
Thanks again. So, Nick, we got another question from Nick. How often do these things get struck by lightning, and how does it affect them? I know you touched on that just now.
Yeah, I think they get hit quite often, actually. I know that it damages the blades, and that guys, rope access guys, come in and repair them. Generally, they have their own rope access guys, Vestas and Siemens, and they're specialists in blade repair. You know, but we have a lot, from a health and safety point of view, we have a lot of instruments in the turbine which detect when there is static in the air. So we've got procedures in place for that. So there's places on the turbine where you can stand if you get caught out and there is a lightning in the area. There's like safe areas within the tower and in the cell that you can stand. How often? I don't know. Pretty often, yeah. Worst case scenario, an installation vessel has to come in and do a blade change out. So they'll actually lift all the blades off and put a full new set on. Blades are balanced, so you can never just replace a blade. The blades are put together in sets of 3, and they've all got exactly the same weight and exactly the same center of gravity. So just like the wheel on your car when you get a new tire, and they put little weights in to make sure that it doesn't wobble. It's exactly the same with turbines. So if one does get damaged, all 3 have to come off and get replaced, and then they would get repaired, and then they would be put on the next turbine that needs it, and so on. So that's what happens there, unless it's a small one. Yeah.
Okay, thanks, John. Another one from Nick. During commissioning, when operatives are on the turbine itself, how is welfare provided for workers to comply with the CDM regs?
Well, there isn't. There's welfare provided to them by the vessels that they're coming off of. So if they're going on by CTV, then the CTV has the welfare. So they've got toilets and facilities. And then obviously if they're going on by a walk to work vessel, the welfare is on the walk to work vessel. There is a little bit of welfare on there. So there's a kettle. Generally they take a little kettle with them, and they take a packed lunch. They're provided for very well, actually. The commissioning boys, the galley provides them with a little packed lunch, and off they go. Yeah.
Okay, John, I think, Paul, that's all the questions that I can see there. So
Great,
thanks for
yeah.
answering those, John. Back to you, Paul.
Yeah, no, so thanks so much. I mean, that's absolutely fascinating as well. And, you know, I'm just obviously looking at the other comments coming through, and everybody's putting in sort of messages there to you, John, about how well received that is, fantastic presentation, etc. So I think we'll all agree with that. It's been a fascinating period of time this evening. So, you know, thanks so much for joining us. It's been, yeah, really interesting. Thanks to you, Sean, as well for doing those questions for us at the end as well, and thanks to Simon as well from the committee as well. So yeah, super, everyone's putting in that, so we'll capture all of that. And just to wrap up then, obviously we'll make the recording available on the website like we usually do, and I'll send out a feedback survey following the meeting now, so please fill that in, tell us how you think things went. You know, we're always looking for that, for you know, to try and help improve. You know, we've got a great committee here, lots of interesting topics coming up as well, so please fill that in as well. Thanks to Nick as well for questions as well, great this evening, really great to get that going as well, really appreciate that as well. And look out for obviously the programme from the branch coming up for the new year coming as well. You know, we are going to look at a hybrid model, so there will be a continuation of this virtual presentation, but also there will be some face-to-face meetings as well planned for the year ahead as well, so look out for those. And you know, final thing from me really is thanks ever so much for taking the time to join us, and you know, keep looking out for those IOSH virtual meetings. You can go and join any of those meetings at all. You don't just have to join the West Wales ones, but make sure you do come back, and we'll see you again hopefully next month. So thanks again, and we'll be in touch. Thanks a lot. Thanks everybody. Take care. Bye-bye. Thanks a lot. Bye-bye.
Bye.